Hello everyone, welcome to the online course Analog Circuits. I am Nagendra Krishnapura. I am from the Department of Electrical Engineering at IIT Madras. This is an introduction to the course. First we will go through what analog circuits are, then see what the contents of the course will be, and go through what we hope to achieve by learning this course. Okay. First of all, what are analog circuits? Now, put very simply, they are circuits that process analog signals. Now, many of you may be familiar with different types of signals. They are shown here. At the top left, I have shown something that is labeled as analog, and here if you observe, there is some signal that is varying with time, and the points are defined for every value of time, that is, it is continuous in time, and also the values can be anything along the y axis. So, it is continuous in amplitude. So, if it is continuous valued or continuous in amplitude and is defined for continuous time, then it is an analog signal. Okay. More specifically, it is a continuous time analog signal. Now, what are the other types of signals? It is possible that the signal is defined or signal changes only at discrete instants of time. Okay. The discreteness of the time axis is marked here. This is the bottom left picture. So, these tick marks denote instants at which the signal can change. You see that it changes only at discrete instants of time, but the values along the y axis can be anything, and such a signal is known as a discrete time continuous valued signal or a sample data analog signal. Okay. And you can have the counterpart where the signal can vary at any instant of time. This is shown on the top right, which I have labeled as continuous time digital. So, the signal can vary at any instant of time. So, the x axis is continuous, but it can only take on certain discrete values along the y axis. Okay. So, this is a continuous time digital signal, and this is not very often seen, but it is very much possible to have this. Finally, you could have discretization along both x and y axis, that is, the signal changes only at discrete instants of time, and it also will take on only discrete values. This is known as a discrete time discrete valued signal, or more commonly as a digital signal, and you would be familiar with a particular variant of it, where there are only two possible values along the y axis. That is a binary digital signal, but that is what you would normally call a digital signal. Okay. So, this is an analog signal and this is a digital signal, and analog circuits are circuits that process analog signals. Now, that is one definition of it, but that definition is almost completely useless for you to understand what we will be talking about in this course. Okay. Because there is a variety of circuits that process signals like this, which we will not be talking about at all, which you have learned in a previous course. For instance, if you have circuits that are made of resistors, capacitors and inductors, they will of course process signals like this, signals that are defined for every instant of time and can take on any value. Okay. And the output of those circuits, let us say RC circuit or RLC circuit or just a purely resistive circuit, will also be continuous valued and will be defined for continuous time, okay, if the input is continuous time. So, that definition is useless. What do we really mean by analog circuits? They do of course process analog signals. What we mean are really amplifiers, that is active elements. Okay. So far all the elements that you would have studied and the circuits using those elements would have been passive. Okay. Now, we will come across some elements which are active elements. Now, we will look at the definition of this more carefully later, because as you know, passive devices are devices which consume energy, whereas active devices can generate energy. In reality, no physical device can generate energy by itself, it has to be provided from elsewhere. So, there is a particular definition of active nature of circuits that we will see later, but clearly you would not have seen amplifiers till now in your basic circuits class, and that is what we are going to study in this course. In particular, that means that these amplifiers are control sources. Okay. For instance, everyone would be familiar with an audio amplifier. So, it takes the sound from the microphone, amplifies it, that is, makes the value larger and place it on a loudspeaker. Now, I can also think of that as some sort of a control source, let us say a voltage controlled voltage source. It takes the voltage from the microphone and multiplies it by a certain number k and gives you an output voltage which is dependent on the input voltage. So, it is a dependent source or a control source. So, these amplifiers are basically control sources. Okay. Now, you would of course be familiar with those, that is control sources, and you would have seen them in your basic circuits class, but you do not know how to make them, okay, how to construct them, because they are just taken as definitions, that is some control source is given to you and they follow a certain rule. In this course, what we will do is to realize those control sources and also understand their limitations. Okay. And these amplifiers are part of all electronic gadgetry. Okay. Although I started off saying they process analog circuits, it turns out that amplifiers are also part of digital circuits. Without amplifiers, you could not make any digital gate. Okay. And they are absolutely everywhere around us today. We are surrounded by electronic gadgets. I am hooked on to this collar mic here. It has an amplifier inside. I am using the stylus. I am using a tablet PC. I am recording myself on a webcam. So, it is everywhere around me and around you as well. All of you will have mobile phones and all sorts of other electronic gadgets. Okay. So, just to show you an example, I have taken some picture from the web of a mobile phone, and it has what are distinctly analog circuits such as audio, digital to analog and analog to digital converters, and RF amplifiers and so on, and RF and power circuits. Also, like I said, even in digital logic circuits you need to have amplifiers. So, even in memory and microprocessor and control logic and DSP you will find analog circuits. Okay. So, what is this course all about then? It is about amplifier devices and circuits. Now, in this course we use MOS, that is metal oxide semiconductor device, as the amplifying device. That is because MOS technology is the dominant technology of the day, but the principles that we learn in this course are useful even if the kind of device changes. Okay. Some of you may know a bit of history. First we started with vacuum tubes, then we had bipolar junction transistors, then MOS transistors. And there is also a number of other varieties of transistors in different processes. The most predominant technology today is MOS technology in silicon, but you do not have to use silicon and you do not have to use MOS. There is a variety of other materials and other types of transistors. All of them, once you understand the model, can be understood, analyzed and designed using the principles you learn from this course. Okay. So, tomorrow let us say if someone invents a different technology, you have a different type of transistor or a different type of amplifying device, you should still be able to analyze circuits using them and also design circuits using them. Okay. Now, what good is this course? It turns out that this course is prerequisite for analysis and design of all active circuits. Okay. So, if you want to take up a job in IC design or do research in IC design or design any kind of analog and RF system or power electronics and so on, you need to be able to use the principles that you learn in this course. Okay. What are the course topics? First, we will look at the need for nonlinear elements. So far, you would be familiar only with linear elements. Now, we will look at the need for nonlinear elements, and it turns out the need is really amplification. I said that in this course, we will mainly deal with amplifiers, and in order to make useful amplifiers, you need to have nonlinear devices. Okay. You just can't make them with only linear devices. And we will look at one example of the amplifying device, which is known as the NMOS transistor, and it turns out that we have what are known as biasing arrangements. That is, we have to set up certain operating voltage and current in the device, and then on top of that we have to apply the signal that we want to amplify. So, all this will become clear later in the course. Then we will come to the most basic form of amplifier, which is known as a common source amplifier. Then we will look at other control sources. Okay. It turns out that in order to realize this, we have to use negative feedback. So, we will also touch upon the principles of negative feedback. Then we go to another variety of MOS transistor known as PMOS transistor and try to make circuits using the PMOS transistor. And we will also look at another technology of making transistors, which is the bipolar technology, and these transistors are known as bipolar transistors. We see how to make circuits with them and also understand key differences between bipolar transistors and MOS transistors. Okay. This is a more detailed list that shows you week by week what topics we are going to cover. It is approximately right. There may be small changes here and there, and you can of course access this on the course web page. I am not going to go through it item by item, but the entire course I expect will last 11 weeks, It includes a sort of complete set of topics that you need to understand this basics of amplifiers, but the first 8 weeks will be taken into account for the certification test. That is, if you want to write the test will be based on the first 8 weeks, but of course, you are encouraged to go through the last 3 weeks as well in order to gain a better understanding of the remaining topics. Okay. The course structure will be about 2.5 hours of lectures per week. It will be split up into 2 units usually, and each unit will be split up into smaller lessons, usually lasting 10 to 15 minutes. There will be assessments after each lesson, and then there will be assignments after each week. Okay, and it will be due the following week, and I expect the workload to be 5 hours besides watching the lectures. This is to be able to understand everything properly and to do the assignments. Of course, it varies very widely between different kinds of students depending on your background and so on. Okay. So, the course goals are to understand basic amplifiers, that is how the basic amplifier topologies come about and so on. Calculations involving amplifiers, that is calculations involving what are known as large and small signal conditions. We will see these things later in the course. And one of the things that we try to do in this course is not only tell you that something is an amplifier, but try to give you the logic of how the topology came about. And this is very, very important, because even with a single transistor there is a variety of amplifier topologies, and as the number of transistors increases, the number of topologies simply blows up. Okay. So, in order for you to make sense of any complicated circuitry, you have to understand the logic behind the simple building blocks such as single transistor amplifiers. Okay. There is no way you can memorize all the circuits and all the results pertaining to them. Okay. When you look at any circuit, you have to kind of break it down into smaller pieces, understand what each piece is doing, and also what the entire circuit is doing. Okay. Then we will also look at biasing principles, different ways of setting up operating points in a transistor, and also how to combine variety of biasing arrangements with a variety of amplifiers. Okay. In short, if you learn things well, after this course you should be able to recognize and analyze any amplifier topology that you see, and the keyword here is systematically. Okay. I do not mean memorizing some formula somewhere and somehow getting the right answer. You have to be able to understand the logic behind the circuit and use whatever approximations are necessary and come to the correct answer. Now, one of the things that is important in a course like this, and in general in any advanced course in any field, is the importance of approximations. Okay. The exact formula are so complicated that even if you find them and plug all the numbers and get the exact answer, you won't get any insight into the mechanism behind whatever it is that you are analyzing. Okay. So, we will frequently use approximations, but please understand that approximations are not the same as sloppy calculations. Okay. So, in fact, they are more difficult than doing the calculations exactly, because some approximations are good only in some contexts. So, you have to understand the context, understand which approximation is appropriate for it, and use it properly. Okay. Now, in order to go through this course, you need to know certain things. One, of course, is circuit analysis. You have to know how to analyze any circuit, that is any linear circuit containing R, L and C. This is something that you would have learned in courses such as basic electrical circuits, and there are a number of references that I have listed. If you feel a little rusty about these topics, you can go back to them and refresh your knowledge. And you also need to know Laplace transforms. We won't be using them extensively, but we do need them for understanding certain things, and of course, you need to know basic calculus and differential equations and so on. Okay. And here are some resources if you want to brush up your prerequisites. There is the NPTEL course on basic electrical circuits, that is available at this URL, and there is also the electrical and magnetic circuits. Both of these are for basic circuit analysis. And for Laplace transforms, there are NPTEL courses like networks and systems available at this URL. Okay. And for this course, you can refer to this book. We won't be following this exactly, but you can find a lot of material in there, and you can also find video lectures from our group at IIT Madras available at this URL. Okay. And of course, during the course, the online forum is very helpful. You can discuss things with me or the teaching assistants or with other students, and also we will have regularly scheduled hangouts for discussions, maybe 2 or 3 times through the course. Okay. You can use that as well as a live discussion medium. Okay. Enjoy the course.